Hello everyone, welcome back. In the previous videos, we have learned Thumb-1 arithmetic, logical, compare, shift and data movement instructions. We also learned how to switch from ARM mode to Thumb mode. Now it's time to learn one of the most important concepts in Thumb-1 programming, that is branch instructions. If you have already learned ARM mode, you might be wondering, why can't I simply write instructions like move if equal, add if equal in Thumb mode? Let's find out. In ARM mode, most instructions can be conditionally executed. Here, CMP compares the two values and updates the CPSR flags. Then, move if equal executes only if the 0 flag is set. Similarly, add if not equal executes only if the 0 flag is clear. Notice that we never changed the flow of the program. We simply attached condition codes directly to the instructions. If we try exactly the same thing in Thumb-1, Keil reports an assembler error. This is not a limitation of Keil, it is a limitation of the original Thumb-1 instruction set implemented by the ARM7 TDMI processor. Unlike ARM mode, Thumb-1 does not allow most instructions to carry condition codes. So how does Thumb-1 make decisions? Instead of attaching condition codes to normal instructions, Thumb-1 uses conditional branch instructions. The comparison still updates the CPSR flags exactly as before. But now, instead of executing a conditional instruction, the processor executes a conditional branch. If the condition is true, execution jumps to another location. Otherwise, execution simply continues with the next instruction. This is why branch instructions become the primary mechanism for controlling program flow in Thumb-1. Let's now look at every branch instruction supported by the Thumb-1 instruction set on the ARM7 TDMI processor. The very first instruction we notice here is a branch instruction, but what we need to note here is it's an unconditional branch. As soon as this particular branch instruction is encountered, directly the branch happens to the specified label without checking any conditional flag. Next, we have branch if equal. In this case, branch happens if 0 flag is set as 1. Next, we have branch if not equal. Here, branch happens if z equal to 0. Here, branch happens if carry flag is set as 1. Next, we have carry clear or unsigned lower. Here, branch happens if carry is set as 0. In this case, if the negative flag is set as 1, in that case branch happens. And here branch will happen if negative flag is set as 0. In this case branch will happen if overflow is set as 1. And here branch happens if overflow is set as 0. Next we have branch if unsigned higher. Here branch happens if carry is set as 1 and 0 flag as 0. Here we have branch if unsigned lower or same. Branch happens if in case carry is set as 0 or 0 flag is set as 1. Here branch happens if n equal to v, that is negative flag equal to overflow flag, while in case of branch if signed less than, branch happens only if n is not equal to v. In case of branch if signed greater than, 0 flag should be 0 and negative and overflow flag must be equal. And the last thing we notice is branch if signed less than or equal. Here branch happens if z is 1 or n is not equal to v. BL is used for function call. It will branch to a subroutine and simultaneously save the return address in the link register. The called function later returns using the instruction bx followed by lr or an equivalent return sequence. Bx is nothing but branch and exchange. It branches to the address contained in a register. The processor also examines the bit 0 of that address to determine the instruction set. That is 0 for ARM mode and 1 for thumb mode. Let's now implement a simple Thumb-1 program that demonstrates how branch instructions control program execution. Now let us run this simple code and see how it works. First of all, let's check if there are any errors. No errors. So we'll go ahead with debugging. The very first thing you notice here is the assembler directive area, which defines a section of memory to store this information. Thumb code is the name I have given to that section of memory. Code indicates that section of memory contains actual instructions. Read only because we don't want any modification to be happening to that particular code during runtime. ARM here is an assembler directive which informs that the next set of instructions should be considered as 32-bit instructions. By default, the processor will be executing the instructions in ARM mode itself. So it will work even if you don't specify this. Entry is an assembler directive which indicates where exactly execution starts. The very first label after entry is the location where the execution actually starts. That is this label. Start, thumb start, higher, lower, all these are nothing but labels. In the very first instruction, we are loading the address associated with thumb label into register R0. The address associated with thumb start is nothing but 8. Okay, so +1 means the address 9 will be loaded into register R0. But remember one thing, the address that the control jumps to will be thumb start itself. This addition of 1 is done just to indicate that the processor needs to execute these instructions in thumb mode. Okay, and if in case you don't add it by yourself, it will be automatically added by the linker and assembler because it appears under the thumb directive. Okay, so let's continue for now. Address 9 is now loaded into register R0. BX R0 will now jump to the address stored in R0, and by checking the last bit, which is 1, it will know that the processor needs to execute thumb instructions. So now if you see here, T bit is set as 1 because processor has now entered thumb mode. In the very first instruction that we see here, we are loading the value 25 into register R0 and 15 into register R1, and then we are performing comparison. The comparison between R0 and R1 performs internal subtraction and it will update the CPSR. And we already know 25 is greater than 15. So out of these conditional codes or conditional branches, the very first one will be executed. This will be executed anytime carry is 1 and Z is 0. But this instruction will be executed if in case carry is set as 0 and branch equal will be executed if Z is set as 1. Since this conditional code is currently true, we will branch to the label higher. And we are moving R2 with the value 1. And finally, we'll jump to the infinite loop. If that was not the case and if first value was lower than the second value, we would have jumped here and loaded R2 with the value 2. In the third case, R2 would have been loaded with the value 3. But since 25 is greater than 15, the final value loaded in R2 is 1. This is nothing but an unconditional branch. That's all about this video. I will see you in the next video.